Hi everyone, welcome to the second video on syllogism. As discussed in my first video on syllogism that I will cover both the methods, first without the Venn diagram method, and in this video we will look at the Venn diagram method. So how I have divided this video is, this video will primarily touch upon the concepts of Venn diagram. So in the next video, I'll be actually taking questions and solving questions through Venn diagrams, but it's imperative that you have a solid foundation. So I thought we'll cover all the concepts, look at how to arrive at different possibilities before we learn the minimum overlapping concept and start solving questions. So let's get started. So first things first, what is the concept of Venn diagram? So I'm sure in school we remember that we must have studied set theory. That means in our earlier classes, the concept of sets is like that. So for example, let's say A equals to A is a set wherein there are certain numbers in A, let's say 1, 2, 3. There is B and there are certain numbers in, let's say B, let's say 1, 2, 4. And let's say there is another set C which has numbers like 1, 2, 3, 4, 5, 6, etc. Okay, so these are three sets. So we learned the concepts of subset, we learned the concept of superset. So for example, if I were to represent these A, B, C in a diagrammatic fashion, that is nothing but your Venn diagrams. I can say, let's suppose this is your A and let's suppose this is your B. So what it means is that the common part, so your 1 and 2, these are the two elements that were common if you see here in A and B, right? Where in B alone you had 4, in A alone you had 3. So this is how you could probably represent. Now if you were to represent C as well, how you could do that is, you can say, okay, C is like the superset because C contains all the elements of A and B, right? So let's say C has 1, 2, 3, 4, which is here, and 5, 6. So C has also these additional elements. So basically Venn diagrams is the diagrammatic way to represent the sets, and that's what we do here. So that means the question format again would be same. So like how we have the terms here, how we had the elements here, similarly here you have these terms: bats, mammals, birds or bats. So in the premise you have two statements and each statement has two terms, right? And there is a particular way how you see the relationship, which is described by this all bats are mammals. That means between bats and mammals, the relationship is of which format? Is of the universal affirmative, right? Universal all. And similarly here, this is universal negative between birds and bats. So what we are supposed to do is, we are supposed to merge these two statements and we are supposed to say whether we can deduce these conclusions from these two statements. That is what our deductive logic is, our syllogism is. Okay, so in similar fashion like how we did earlier, so we will be looking at things like universal affirmative, different types of statements. So broadly there are 4 types of statements: your universal affirmative, universal negative, particular affirmative and particular negative. So that's what we will look at. So before I explain what do we interpret from these statements, there's a word of caution. So one is, do not use reverse logic in these questions. What does that mean? That means that if somebody is saying all cats are dogs, that may not necessarily mean all dogs are cats. We'll stick to facts, we'll stick to the rule and understanding and not applying too much of common sense and worldly knowledge like how we do in inductive logic. All right, so let's look at the first statement. The first statement is universal affirmative statement. It says all cats are dogs. So let's understand this relationship through Venn diagrams. So if I were to say, how can I represent this all cats are dogs in a diagrammatic fashion? How can we do that? So let's say if I say, how about I write something like this? I say, okay, these are two diagrams and let's say it is this, dogs and cats. So is this a true representation of this? So can I infer that this is the correct possibility of this? It says all the cats are dogs. Now cats, look at this element, right? So let's say this element is nothing. Let's say this is a cat. Is this cat a dog? No. That means, is this actually representing this statement? No. Therefore, this is not the correct diagram. How about this? If I say all cats are dogs, can I say that this is a correct possibility? Can I say that? This is P1, correct possibility of this? Yes, because all the cats, you look at all the cats are in the dog circle, right? That means we can say all cats are dogs. So that is exactly why I was saying no reverse logic. That means if you say all cats are dogs, it does not necessarily mean all dogs are cats. For example, if I say all Keralites are Indians, can I also say that that means all Indians are Keralites? That would not be true, right? So that is exactly what I'm trying to say. So this is your first possibility. Now, is there any other way to represent this? Any other possibility? How about this? Cats, comma, dogs. That means you have the same circle for cats. That means cats equals to dogs. So this is your second possibility. Now, how to check whether this is true or not? All you have to do is whether this is satisfying the condition. The condition says all the cats are dogs. So are all the cats. Can you find a single cat which is not a dog? No. That means this is also the correct possibility. So there are two ways, two possibilities to this particular statement, universal affirmative. Okay, let's move on. Let's look at the second type of statement. It says no cat is dog. So that means for cat, let's say this is the diagram for cat and this is the diagram for dog. It says no cat is dog. That means these are disjoint circles, right? These are disjoint sets. There is no element of cat which is a dog. That means there is no intersection, right? So this is how we can represent. Now there is only one possibility. There is no other way you can represent this. Okay, let's move to the third statement. The third statement says some cats are dogs. Now what does this statement mean? So if you were to represent this through a diagram, right, how you can do that? So for example, most of the people will get this one first, right? So they'll say this is cats, this is dogs. So they're saying, hey, here is the intersection. So this represents cats are dogs, some cats are dogs, and this is absolutely fine. So this is one possibility. But I want you to pause the video here and think about more possibilities. If you can represent this statement through more diagrams. So this is one possibility. What is the other possibility? So let's say, can we say this? How about this? Is this a correct possibility? Some cats are dogs. Can this be the second possibility? Now most of you will say this is not correct. And why? Is because you're saying it says some cats are dogs. It's not saying all cats are dogs. And that's where I said, please do not use common sense or worldly knowledge. Now the problem is we do not know what some actually means. So technically speaking, in the deductive logic parlance, some means at least one. At least one, please. And I think this is news to a lot of people. Some means at least one. The moment it says some cats are dogs, so don't say that it is all cats are dogs. Don't worry about that. We don't have to use reverse logic. All we have to say is whether this diagram is satisfying the condition that at least one cat is a dog. At least one cat, can you say, is a dog here? Of course. So that means this is a correct possibility. Okay. What other possibilities can we draw? So that means at least one cat is a dog. So how about this diagram? How about this diagram? Is this a correct possibility? I am saying at least one cat is a dog. So look at this element. Is this element in the cat circle? It's also in the dog circle. That means this is also a correct possibility. So this is your third possibility. So we have discussed three possibilities. Do you think there is any more possibilities? Think about it. How about this case? If I say, that means it says at least one cat is a dog. So this is the extreme case of this equation, right? And this is also a correct possibility. See, we are discussing possibilities. So all these are possible cases because all these diagrams really satisfy this condition. So that means for particular affirmative statement, there are four types of diagrams. Okay. Now let's look at the last one. It says some cats are not dogs. So now that you know some and what is the meaning of some, So we said some means at least one. Can we now try? So I would request you to pause the video again and try on your own. So some cats are not dogs. So how can we represent this? One is our standard Venn diagram where we are saying some cats are not dogs. So I'm saying this shaded region. These are all cats that are not dogs. So at least one cat. So for example here, at least there is one cat which is not a dog, and which is fair enough. So this is possibility 1. What other possibility can we draw? How about this one? I'm saying at least one cat is not a dog. So look at this possibility. Is this cat a dog? It's not a dog. That means it is validating the condition. So that means this is your possibility number 2. And again, also look at the extreme cases. At least one cat is not a dog. How about this diagram? If I say this is cats, this is dogs, this is we are saying at least one cat is not a dog. And here, in fact, none of the cats are dogs, right? Not a single cat is dog. That means this is also validating the condition. So this is what we mean by understanding the possibilities through these Venn diagrams. We looked at 4 types of statements: universal affirmative, universal negative, particular affirmative, and particular negative. And we looked at all the possibilities. So for universal affirmative, all cats are dogs types of statement, we looked at how many possibilities were there? Possibility 1 and possibility 2. For universal negative, it was the simplest case. How many possibilities were there? Only one possibility was there, right? Disjoint sets. For this special case, which is particular affirmative, there were 4 possibilities, if you remember, because we understood that the meaning of the term some means at least one. So there are 4 possibilities. For some not, that means particular negative, we looked at the cases and we found how many possibilities? 3 possibilities. So before we really move ahead and start solving questions and start understanding the concepts of minimum overlap, my request to all of you would be that please be very, very thorough and clearly understand all the different possible cases that arise out of these 4 typical conditions, and then we will solve more questions. So thanks for watching the video, and I look forward to seeing you in the next video where we will solve questions and understand what is the concept of minimum overlap.